These are the two questions from two different variants of October-November 2021. Now, I'm labeling this question on my left-hand side as question number A and on my right-hand side as question number B. Now, both the questions are related to the apparatus setup. We can see in the on my left-hand side, the question number A, the setup A, we can see over here that we have a condenser and which is fitted over a round bottom flask, but the condenser is in the upright direction. In the setup B, we can see again the condenser here, but the condenser is in the slant position. Now, why we are keeping the condenser in the upright direction and why we are keeping in the slant position, that depends on that after condensation, where do we want a condenser, a liquid condensed liquid to fall in. If we have it in the upright direction, we call the condenser as the reflux condenser. We call it a reflux condenser. Okay? In this scenario, what happens that when the vapors they enter the condenser, they after condensation they fall back into the same reaction flask, and the condenser in the picture B or in the second question, it is in the slant position, right? In this scenario, we call it a Liebig condenser. We call it the Liebig condenser. Now, why do we have the condenser? Condenser. Here again, the spelling mistake is here, condenser. Now, why do we have the Liebig condenser or the condenser in the slant position? Because in this, the vapors, when they enter into the condenser, they condenses into the vapor liquid form and they fall back into a new conical flask, or they fall back into the new receiver flask. So depending on the scenario, depending on the situation, do we want the liquid fall back into the same reaction flask? If that is the scenario, we go for reflux condenser. If we want the liquid just say vapors to condense and the liquid to fall in a new conical flask, then we'll be going for a Liebig condenser, right? So there's a special purpose for when we are going to have it in the upright direction and when we are going to have it in the slant direction. Now, before we go back to the apparatus setup, let's recap some of the important organic reaction. Now, here in front of us, we have the oxidation of alcohol. Now, when an alcohol it oxidizes, we can easily remember that the alcohol it oxidizes in the presence of an oxidizing agent, which is basically your acidified potassium permanganate. जिसको हम equation में oxygen we can write it down in the square bracket. That means it's been oxidized. Now, well, when alcohol oxidizes, it gives you an intermediate compound. Now, this intermediate compound, remember, that exists in the gaseous state. This is step one. So alcohol do not directly convert directly into oxalic acid, into carboxylic acid. In fact, it first convert into an intermediate, then this intermediate again undergo an oxidation process, right? And it converts into carboxylic acid. So it's a two-step reaction. Alcohol converting into intermediate is step one, oxidizing to get you intermediate, that's step one, and intermediate again giving you carboxylic acid, that's a step two, that's again an oxidation. Now let's see how this apparatus setup help us in this particular process. Now, as I've explained you right now that this alcohol do not directly oxidizes into the carboxylic acid. So what happens here, that alcohol, it is reacting with an oxidizing agent, that is acidified potassium permanganate, right? And it will be giving you an intermediate, and that intermediate exists in the gaseous form. So definitely it's going to rise up, and we have a condenser attached as an A. तो होता क्या है यहाँ पे, जो condenser जो है उसके अंदर it has an inner jacket, inner tube, and it is surrounded by the outer jacket, which is gray in color, which is depicted as gray color. Now what is happening, the water will be circulating in the outer jacket, which is going to condense the vapors which are in the inner tube. So they condenses and they fall back into the same reaction flask. तो आपका जो इंटरमीडिएट जो गैसियस स्टेट में था, जो वेपर्स के फॉर्म में ऊपर गया, कंडेंसर ने इसको वापस कंडेंस करके सेम रिएक्शन फ्लास्क में ड्रॉप डाउन ड्रॉप करा ताकि उन वेपर्स का उस गैसियस इंटरमीडिएट कंपाउंड का सेकेंड स्टेप में ऑक्सीडेशन हो और उसके बाद वो कन्वर्ट हो जाए इनटू योर कार्बोक्सिलिक एसिड. So that is actually the purpose of reflux condenser, which is in the upright direction. So I told you the two differences between the Liebig and the reflux. Number one was a difference in the position, and number two कि वो कंडेंस होने के बाद आपका जो लिक्विड है वो सेम रिएक्शन फ्लास्क में गिरेगा या आपका डिफरेंट रिएक्शन फ्लास्क में गिरेगा. ठीक है. रिफ्लक्स कंडेंसर में आपका लिक्विड आपके वेपर्स आफ्टर कंडेंसेशन दे फॉल बैक इनटू द सेम. That is the reason we have the reflux condenser here. Now, when we talk about the Liebig condenser, the vapors they enter here, they get condensed, condensed here, and they will be falling back into a different reaction flask. So that is the basic difference. So we are using the reflux because we want the vapors after condensation to fall back into the same reaction flask. Now, another very important point related to condensers. Now, as I told you that the condensers are made up of two tubes. They have an inner tube and they have an outer jacket. So this gray one is an outer jacket, right? This is an outer jacket. Or is outer jacket के अंदर इस आउटर जैकेट के अंदर आपका वाटर जो है सर्कुलेट करता है ताकि वो इनर जैकेट के इनर जो इसकी ट्यूब जो है विच आई एम मार्किंग ओवर हियर विद ब्लू, ये इनर ट्यूब के अंदर जो भी आपके वेपर्स जो आपके यहाँ पर हैं उनको कंडेंस करे. ठीक है. ये इनर ट्यूब के अंदर जो भी वेपर्स जा रहे हैं उनको कंडेंस करे. ठीक है. तो इसके अंदर जरूरी है कि आपका जो वाटर है वो पूरी आउटर जैकेट को फिल करे. अगर हम वाटर इन ऊपर से करते हैं तो वाटर ऑटोमेटिकली वॉल से होता हुआ नीचे से और आउटर वाटर आउट से निकल जाएगा. लेकिन अगर हम इसका रिवर्स करते हैं, अगर हम इसको वाटर आउट बनाते हैं और इसको वाटर इन करते हैं तो क्या होगा? वाटर इज पम्प्ड अप, इट्स पुश्ड अप. तो व्हेन इट इज पुश्ड अप इट इज गोइंग टू फिल द कंप्लीट आउटर जैकेट, जिसकी वजह से वेपर्स जो होंगे वो आपके कांटेक्ट में आएंगे कोल्ड वाटर के और जिसकी वजह से वेपर्स आपके कंडेंस होंगे. तो हमेशा याद रखिए कि कंडेंसर का ऊपर वाला जो होता है ओपनिंग होती है दैट इज ऑलवेज वाटर आउट एंड द इनर द लोअर ओपनिंग इज ऑलवेज वाटर इन, जिसकी वजह से क्या होगा? the cold water is forced into the outer jacket and it is pumped out from the upper opening so that the inner tube के जितने भी vapors होंगे वो condense होंगे. ठीक है. तो अब यहाँ पर normally they give you this as an error. ये हमेशा ही करते हैं कि ऊपर वाले को water in show करते हैं और नीचे वाले को water out करते हैं. अगर ऐसा है तो condenser का ये error है in the labeling. तो upper one should always be your water out and the lower one should always be a water in. So whenever they assemble the condenser और diagram आपको show करते हैं label diagram, तो हमेशा ये देखिए कि नीचे वाला in है ऊपर वाला out है. अगर ये reverse इन्होंने किया then that is an error. Okay. तो ये often they ask you to mention the error here. Okay. Now take one question at a time and go into detail because we have done the comparison between reflux and Liebig on the basis of the position and on the basis of that after condensation where the liquid is collected, right? Now let's go back, let's go question by question here. Now name the apparatus A. We already know that the apparatus A is basically, I'm talking about question in A part, right? So A is basically your condenser, which we'll be naming as reflux condenser, and B is basically my round bottom, or I can also call it a distillation flask. Okay. Now further going down, let's see what else. Identify two errors in the sample apparatus shown in the diagram. So the two errors are error number one. What is the error number one? This should be water out and this should be water in. That's one error. And the second error could be that we are heating any organic compound. Heating of any organic compound directly is an error because we know that the organic compounds are basically flammable, so we cannot heat them directly. So heating an organic compound directly is an error, because that's going to, because of this, what will happen, the mixture can catch fire. So the two error, it identified two errors in the assembling of the patterns is that the water in should be water out, or the lower one should be water in, lower opening of the condenser should be water in, and the upper opening of the condenser should be water out, should be water out. And the second is we cannot heat the organic substances directly. Now the error are corrected, the experiment is started. State why apparatus B is not heated directly using the flame of the Bunsen burner. It's not used because we have already told that's flammable, because organic substances are flammable. Name a piece of apparatus that is used for heating without the flame. So without the flame, you can indirectly heat it through water bath, or you can heat it through sand bath, or you can heat it indirectly through um, oil bath, right? Apart from that, heating with the apparatus A in the vertical position is called reflux. What describe what happens after the vapor from the apparatus A enters the B. So after the vapors from, what happens, let me read it again. Describe what happens after the vapor from the apparatus B enters apparatus A. So when they from B, when they enter the apparatus A, what will happen, they will condense and they'll fall back into the same reaction flask. So this was the question from variant 4.1. Now let's focus on the question from variant 4.2. Now, in this particular question from variant 4.2, they have a Liebig condenser, and this setup is clearly telling us that we have a fractionating column. Now, what do we have here? Let's see the question. We have a mixture of alkanes here. We are heating the mixture of alkanes, and the alkanes, they are going to vaporize on the basis of their difference in the boiling point. इनके different boiling point है जिसके वजह से ये vaporize होंगी. Or we have the setup, we have apparatus B, which is basically my fractionating column. This is my fractionating column. Now, what is the purpose of fractionating column? Now, this fractionating column is filled with, it's normally filled with glass beads. This is filled with glass beads. Now it's filled with glass beads in order to give it a larger surface area for the better condensation, so that the vapors of different alkanes on the base of the different boiling point this separates out. और जिसका भी lower boiling point होगा वो particular by वो temperature को change करता हुआ और फिर condenser में move करेगा वो vapors जिसके boiling point सबसे कम होगा, जिस picture में से जिस जो भी alkane है वो फिर temperature of the thermometer को change करता हुआ accordingly, ठीक है. तो boiling जो भी vapors enter हो रहे हैं condenser, वो temperature thermometer depict कर रहा होगा, because it's next to the arm of the condenser. और फिर वो condense जो हो रहे हैं vapors जो condenser में आ रहे हैं, and the condenser is basically my Liebig condenser because it's in the slant position. और यहाँ पे कंडेंस होने के बाद नीचे वाला जो है वो ओपनिंग इसकी वाटर इन है, और ऊपर वाली जो है ओपनिंग दैट्स वाटर आउट, because you want the water to fill the outer jacket so that the vapors entering it properly condense, and after condensation they need to fall back into the separate reaction flask, क्योंकि यहाँ पर हमें mixture of alkanes को separate out करना है. वहाँ हमारी intention अलग थी, हमें intermediate को same reaction flask में fall down करना था ताकि उनका second step of oxidation हो, but here we want the mixture, the component of mixture to be separated on the base of the boiling point, right? So considering the two different objectives, we have a different position of this condenser. In the upright position we call it Liebig, in the slant we are going to call it in the upright, sorry, we call it reflux, and the slant will be calling it a Liebig. Okay, moving ahead. Now the later part of the questions, they're saying that name the apparatus A and B. So A is basically my Liebig condenser, is B is my fractionating column. Now identify the two errors in the assembling of the apparatus shown in the diagram. So number one error is the same, that the lower opening of the condenser should be water in and the upper one should be water out, right? And the second error is that any organic compound cannot be directly heated. And one more error over here, the other error is that the receiver flask in which we are receiving after condensation the liquid, it should not be corked. We are not going to put a stopper to it. Why? Because after condensation, the liquid which is falling into it, that might create build up pressure because it's still warm, and because of that the liquid might be sucked back again. So it should not be corked, because you are dropping in the liquid, there are no more vapors entering here, so it should not be corked, or there should not be any stopper here. Otherwise liquid will start sucking back into the condenser and back into the mixture flask again. So that is the second error. Okay. Okay, now the errors are corrected. The mixture of the alkane is heated in the flask to start the separation. The boiling point of the alkanes are shown below in the table. They have been given to you here in the table. Different boiling points. The octane has 126, nonane has 151, and decane has 174. So they have a higher boiling point than water, whose boiling point is 100 degrees Celsius. Now state why the flask is not heated directly with the flame of the Bunsen burner. Why? Because the alkanes or any organic compound is flammable. So we know the reason. We cannot directly heat them, because otherwise they're going to catch fire. Now state why the flask is not heated with a beaker of boiling water. That means why we are not going to heat it through water bath. Now what will happen if we are going to use a water bath here? So what will happen here? I'll show you the picture. What will happen here? A water का जो boiling point है वो है आपका water का जो boiling point है वो है आपका 100 degree Celsius, right? उसका boiling point 100 degree Celsius. अगर मैं इसको water bath के through heat करती हूँ, I have a water, तो maximum जो water जो heat होंगे ये एल्केन का मिक्सचर वो 100 डिग्री सेल्सियस तक होंगे, क्योंकि वाटर जो है वो वेपर्स में कन्वर्ट हो जाएगा। जबकि हम यहाँ पर नीचे देख रहे हैं कि इनके बॉइलिंग पॉइंट्स आर मच मोर देन 100 डिग्री सेल्सियस। जब इनके बॉइलिंग पॉइंट्स जब इनके 100 से ज्यादा हैं, तो आपको ऐसा लिक्विड चाहिए जो इनको उस एक्सट्रीम हीट तक ले जा सके। देखिए, have a look. See, the octane has 126, right? Nonane has 151, decane has 174. जैसे जैसे इनका molecular mass बढ़ रहा है, वैसे वैसे इनके boiling points ही बढ़ रहे हैं। तो अब यहाँ पर देखिए, अगर आप यहाँ पर water bath रखते हैं, तो water bath जो है वो maximum temperature को रखेगा जो एल्केन जो आपके एल्केन्स के जो मिक्सचर को हीट कर सकता है वो 100 डिग्री सेल्सियस तक कर सकता है। तो दैट मीन्स ये मिक्सचर कभी भी जो है अपने वेपर फॉर्म में नहीं आएगा। सो वी कांट यूज वाटर बाथ। इंस्टेड ऑफ द वाटर बाथ वी विल बी यूजिंग आइदर ऑयल बाथ or we can use a sand bath, right? So that can be an alternative. Coming to the next part of the question, name a piece of apparatus that is suitable to heat the flask. Name the piece of apparatus that is suitable for heat. So in this scenario, we cannot use the direct heat. We can use the electric heater in order to have the uniform heating there. Now name the first alkene collected in the जिसका भी boiling point कम होगा वो उसका vapors पहले rise होंगे in the fractionating column, and then they'll be moving into the condenser. तो इन तीनों में किसका boiling point कम है? 126. तो पहले इसके vapors आएंगे, फिर इसके vapors आएंगे, और eventually end में आपके decane के जिसका boiling point सबसे ज्यादा है, right? So name the first alkane collected in the conical flask. That's going to be octane, because its boiling point is minimum, right? So this is how you'll be answering this particular question. And the last part is asking about state the purpose of apparatus B. So let's see what is apparatus B. The apparatus B is basically your fractionating column. So what is the purpose of apparatus B? So apparatus B is basically fractionating column, and the purpose is, we'll say that the apparatus B is my fractionating column, and the purpose is to separate the components of the mixture. Its purpose is to separate the component of mixture on the basis of their different boiling points. So that's basically the principle of fractionating column. That's all about